Hello everyone, I will go over with you how to do some of these questions. Now the first one, when 1 pentanol heated with hydrochloric acid and zinc chloride, 1 chloropentane is the major product. This is an what kind of a reaction and what is another product that can be formed. Okay, so 1 pentanol is a primary alcohol and we have chloride as the nucleophile, and when pentanol, OH is going to replace with chlorine or chloride. You know hydroxyl group is not a very good leaving group, so we want to make sure that it would protonate and we can leave it as a water molecule. But in this case, hydrochloric acid is also, the chloride is the poorest nucleophile of the halide ions. So we need extra catalyst. Okay, so the catalyst that we're going to use is the zinc chloride. So I have shown you in the lectures how the mechanism works. So in your pentanol, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, alcohol in the presence of zinc chloride, ZnCl, this oxygen attack the zinc and leave chloride group, so this will become OH, zinc chloride, and then oxygen will become positively charged. And then the next step is the chloride that left is going to attack the carbon next to the oxygen, and that is going to be a bimolecular reaction, and we call it as a SN2 mechanism. So the chloride attack this carbon and leave this HOZNCl, and then the product is going to be chloropentane, 1 chloropentane plus OHZNCl, and also as the major reaction you will also be losing a water molecule. Okay, so plus a water molecule. Okay, so in this process, this is a SN2 mechanism, and also water is also a product, H2O, not hydrogen gas, it's just H2O. Okay, so that's the answer for the first one. And the second one, what is the major product of the following reaction? And now this one is a secondary alcohol, and when you add hydrogen bromide, again oxygen is going to react with HBr, one of the lone pairs of the oxygen, grab the hydrogen, leave bromide, so you're going to have methyl groups and a carbon here and CH3, and then you also have a hydrogen there, and then this oxygen will be protonated. Oxygen with the 3 bonds will make it a positive charge, formal charge, positive, +1, and then the Br minus. Now we have a very good leaving group, a neutral water molecule, so this can just fall off, giving us, this is your side methyl groups, CH3, and this is a secondary carbocation. And if there is a chance that it can rearrange to become a tertiary carbocation, it would do so by using a neighboring hydrogen or a methyl group. Since we don't have any hydrogens on the neighboring carbon, there is a methyl group, so these are 3 methyl groups. So the 1,2 methyl shift can take place, rearranging the carbocation, and now you have this molecule. This is HCH3, CH3, and the secondary carbocation became tertiary carbocation. And then the bromide will attack the carbocation and give you the product, which is this Br. Okay, So that is the product for this reaction. And then the third one, it's asking to draw the mechanism for this reaction. And we have two hydroxyl groups in the presence of the H plus. In the presence of the hydrogen or acidic hydrogen, what will happen to our oxygens? There are two lone pairs on oxygen. It doesn't matter which oxygen. One of these is going to go and grab this H plus, and then it would become a protonated alcohol. And since we are going to make a 5-membered ring, so we can number them 1, 2, 3, 4. There are 4 carbons in our molecule. So you can bend the molecule to give you, so the oxygen, the terminal oxygen carrying now additional hydrogen having a positive charge, and this is your carbon 1, 2, 3, 4, and then fourth carbon also has a alcohol group, OH group. Okay, so now you form this molecule intermediate. Now the water molecule will not fall off by itself because you are creating a primary carbocation which is not going to be stable. So it will facilitate the leaving of the water molecule by attacking the hydroxyl group. Okay, so then this water molecule will fall off and generating a ring structure which is going to be something like that. Oh my, let me redraw it a bit nicer like this. And then oxygen right there. Now the water molecule left, okay, and then the oxygen is still carrying the hydrogen. Because of that, it will still be positively charged, and the water molecule that left, and we are in acidic medium, I'm going to go and grab this hydrogen and give its lone pair back to the oxygen atom, giving us the molecule we want. And then oxygen will have its two lone pairs plus H3O plus. Because we are using catalytic amount of H plus and we generate the proton that we used up. Okay, so that is the mechanism for this reaction. The next one. What is the major product of the following reaction? Now, what do you think about this one? What's the major product of this? Hydrochloric acid, you heat it, and we don't see any zinc chloride here, but that's okay. It's a secondary carbon that carrying hydroxyl group. So there won't be any rearrangement of the cation because it's a secondary carbocation, and we cannot make a primary carbocation, the tertiary carbocation. So we're going to keep it as it is. Okay, so the product formation is obvious here. That's going to be chlorine. Chloride will be replace this hydroxyl group. Okay, without any rearrangement of carbocation. So there would be CH3, CH, CH2, CH3, and then the chloride would be there. And then draw the major product of the following reaction. Again, this is a primary alcohol. When you heat it up with HBr, it would undergo SN1 reaction with bromide. Okay, it would be like this. Benzene ring, Br. Okay, that's straightforward also, so you can look at that one. Okay, any questions over here? No questions. Even if you have questions, how would I know since you are not talking to me? Right? Okay, let's go to the next one. Okay, so what about the major product of this reaction? Again, you're adding hydrochloric acid. Nothing much happening here because we are already going to create a tertiary carbocation. Okay, so the methyl group, again this will form a water molecule, it will fall off, we already have a tertiary carbocation, and then the chloride will go here and attach. Okay, number 7 again, draw the major product of the following reaction. Now what's going to happen over here? So when you add HCl and heat, again the OH will protonate. Okay, so the lone pair, one of the lone pairs, remember oxygen has 2 lone pairs, one of the lone pairs will go and grab hydrogen, and then chloride is going to leave. So you're going to be forming this molecule where you have a protonated alcohol. Okay, like this. Secondary carbocation, and this can fall off, and then you're going to be making plus Cl minus. You have this secondary carbocation, and the carbon where we have the attachment to the ring has a hydrogen there, which is not normally drawn in your skeleton structure. So you can move this hydrogen to this carbocation. By doing that, so this is a rearrangement. So by doing that, what's going to happen? Now we have created a tertiary carbocation instead of a primary carbocation. Okay, so then the chloride can come, and chloride gonna attach to the tertiary carbocation, giving us the product. This, you have chlorine like this, that would be the product. Okay, and then the next one, question number 8, we have thionyl chloride, SOCl2 is thionyl chloride, and pyridine, and this is a chlorinating agent. So basically thionyl chloride will make a good leaving group. Again, we have talked about this in the lecture slides, you can refer to it. And then the final product is going to be attachment of a chlorine or a chloride to the primary alcohol. Cl, thionyl chloride and pyridine. And then we have tosyl chloride with pyridine. Okay, tosyl chloride with pyridine, what are we going to make here? So the product is going to be, now the alcohol again, so this is again, let me see. So the chlorine will replace the OH, but before that the tosyl group will attach to the molecule. Okay, so it would be, you have a methyl group, I have an ethyl group there, this is hydrogen. Okay, and then the oxygen. Before the chloride is going to react, so the tosyl group will add on to the alcohol group, so the product would be OTS. Again, refer to the notes that we did in chapter epoxide, ethers and alcohols, and you will see all these steps. Okay, so the answer is going to be hydrogen will be replaced by tosyl group. And now this is a good leaving group, so then the chloride will come and attack the carbon, leaving OTS group. Okay, whereas with thionyl chloride in the previous one, thionyl chloride and pyridine, it will go all the way to chloride at this step. But with the tosyl chloride pyridine, you will get this first before it goes to chloride. And then the next one, sulfuric acid, and you heat it. What's going to happen over here when you heat this molecule with sulfuric acid? Hmm? Now this is a dehydration with sulfuric acid. Again, this can undergo formation of the tertiary carbocation because the OH can be protonated. If it protonate, it would look like this, a protonated water molecule, and then this molecule can leave. Right, in the presence of acid, OH is going to always protonate, and that will end up giving us this molecule. This is carbocation. Okay, so this is a symmetrical molecule. You have hydrogen here, or you have hydrogen over here. So the sulfate ion H2SO4, HSO4 minus, or the water molecule itself, remember it's leaving a water molecule, that also can come and grab one of these hydrogens and form a double bond. Okay, the bond between the carbon hydrogen is going to break and going to form a pi bond between those two carbons, giving you this molecule. It's a symmetrical molecule, so any of the hydrogens I have drawn can do that. Okay, now the next one we have secondary alcohol. Secondary alcohol may or may not form carbocation, but it can always, the alcohol can always protonate first. In the acidic medium, alcohol would tend to protonate, forming OH2 positively charged. When that happens, so it could be E2 mechanism. Okay, so both of these are elimination. So what's going to happen next? So there are two hydrogens that can form the alkene by eliminating a water molecule. Which one do you think is going to be the hydrogen that's going to go away? The mechanism will happen giving us the more stable alkene. We know the Zaitsev rule, which is the more substituted alkene is going to be the more stable one. So if the water molecule, or maybe HSO4 minus, conjugate base of the sulfuric acid, or another water molecule can do this one. I'll go ahead and use a water molecule. I mean, you don't have to do the mechanism. I'm doing some extra steps over here for you. So a water molecule can act as a base. Okay, because we don't have strong bases like hydroxide. In an acidic medium, you can never have a strong base. But water is basic enough because we already have our alcohol group protonated. So it's going to go and grab this hydrogen and then form a double bond between these two carbons and leave a water molecule, giving us the most stable alkene, which is this. But if the terminal hydrogen is left, you are getting a terminal alkene, which is going to be less stable compared to the substituted alkene. So this is going to be the product for this one. Okay, and then the next one, which of the following alcohols dehydrates most rapidly? So which one do you think would give us the most rapid alcohol dehydration? Now you will be looking at which one is the more substituted alcohol, meaning it is going to form the more stable carbocation. Okay, which one is that going to be? This should be quite easy. So this is a secondary alcohol, primary alcohol, tertiary alcohol, secondary alcohol. And you're talking about a dehydration. So which one do you think would be the most rapid alcohol that would dehydrate? That is the tertiary one over here. Okay, so the B would be the most rapid one. What is the major product of the following reaction? Now you have PCl3, phosphorus trichloride, and pyridine. what is happening over here. And we are starting with a secondary alcohol, PCl3 and pyridine. And there is no chance that we can have a better carbocation. So the product would be CH3, CH, Cl, CH2, CH3. Okay. And then the next one, draw the alkene products of the following reaction and circle the major product. Now this is similar to a question that we did earlier. So we have to use dehydration here because you are getting an alkene. It is an elimination. So what are the possible products? So if you draw this molecule OH, again, since we are in the acidic medium, the first step would be protonation of the alcohol. Okay, and then you have two hydrogens that can be removed. So there are some hydrogens here. There are 3 hydrogens there, and then you have another hydrogen here. All the alkene products. So one of the alkene products going to be the water molecule from the sulfuric acid. Remember, when you say sulfuric acid, even the highest concentrated sulfuric acid, that has plenty of water molecules in it, not just H2SO4. Okay, so the water can act as a base. It's going to go ahead and get this hydrogen and then leave. And if that happens, you're going to be getting an alkene like this. That's one of the alkene. And this is HA. And if the HB hydrogen lost, you will be getting a product like that. Okay, so that's another one. And what are the other possibilities we have? Is that all, or can you think of another alkene that it can form? What would be another one? So we drawn 2 of those, and another one would be a rearranged product. Okay, so how does that happen? So the water molecule can fall off, and then you can form a tertiary secondary carbocation. Okay, so let me go ahead and draw that. Let's say you have this, and then if the water molecule leaves, this would have a carbocation, and here on this carbon you have a hydrogen that can do a 1,2 hydride shift. That will give you hydrogen will be here, and then you can have a tertiary carbocation. And then you have hydrogens. Both methyl groups are equal, so it doesn't matter which one. So the water molecule can grab a hydrogen here and give its electrons to form a pi bond right there, and then you can form this one, another alkene. So there are 3 alkenes possible for the first one. So which one is going to be more stable? We have one terminal alkene. Excuse me. This would be having only one substitution on the alkene. And this one has 3 substituents, 3 methyl groups. And this has 2 substituents on the alkene. So the alkene that's going to be more stable would be the one that has most substituents. So this one is going to be the major product. Okay. And then the next one, draw the major product of the following reactions. PbR3 pyridine. It's a primary alcohol. So phosphorus tribromide will replace the hydroxyl group with pyridine. Okay. I'm going to go ahead and clear all the pen markings. but you got the answer for that. Okay, so for this one it would be CH3 to CH2 Br, easy. And then the next one, what is the product of the following reaction? Now chromic acid and sulfuric acid, and this would oxidize an alcohol, and we have a secondary alcohol. So secondary alcohol, the most oxidized product that a secondary alcohol can get is the ketone. Okay, so it would be CH3. So this carbon will become a ketone, and CH2, CH2, CH3. So you kind of have to remember chromic acid and sulfuric acid is oxidizing agent. So the alcohol will become ketone. It's for secondary alcohol will become a ketone. Okay. And then we have number 17. It's asking what is the major product of the following reaction. So in this one, we have a primary alcohol. So the primary alcohol with chromic acid and sulfuric acid, it would take all the way to acid. Instead of stopping at the aldehyde, it's going to go to formation of the acid. Okay. So how would you draw an acid? I'm sure you know how to draw a carboxylic acid. Okay. So the carboxylic acid would be, you have a CH3, 2, CH, CH2, and then the very last carbon that is carrying the hydroxyl group will become carboxylic acid. Okay, so the previous one could not make it a carboxylic acid because it's a central alcohol group, secondary alcohol group. Tertiary alcohol group we cannot oxidize because we have to break a bond, but the secondary alcohol will become a ketone, and the primary alcohol will oxidize all the way to carboxylic acid in the presence of chromic acid and sulfuric acid, which is also called as a Jones oxidation. Okay, and then the next one, number 18. What is the major product of the following reaction? Now for number 18, we have PCC and pyridine. Now this is a special reagent where even though we have a terminal alcohol, under these conditions, this would only stop at the aldehyde level. It doesn't go all the way to carboxylic acid. Now these things you kind of have to remember or maybe memorize. Okay. So, okay, CH3 right there. Did a little mistake over here. CH3. There are two CH3 groups. CH, CH2, and then the final or the terminal carbon alcohol will become an aldehyde. So this is an aldehyde functional group. So this is the product of this reaction. And then the number 19, what alkyl halide is formed in the following reaction? Now we have ether here. Ether you are heating with hydrogen iodide. Hydrogen iodide, what is hydrogen iodide? Is it an acid or a base? It is an acid. So what's going to happen is Hi similar to HCl. Hydrochloric acid is an acid, you guys know about it. Hydrogen iodide is also an acid. Now this oxygen love to be protonated. So in the presence of an acid, this guy goes and grab this hydrogen and leave I minus. So then this would become CH3, CH, CH3. Oxygen will become protonated, and then we have CH2, CH3. Now we left I minus. I'm going to put it over here, carrying its 8 electrons or 3 lone pairs, 4 lone pairs. Now what's going to happen next? Now the ether is going to cleave. Now the next step is going to be SN1 reaction. Okay. If it is undergoing, not SN1, SN2 reaction. Okay, SN2, sorry about that. SN2 reaction. So the I minus is going to attack one of the carbons. If it's going to happen in SN2 fashion, meaning it's a bimolecular nucleophilic reaction. So the carbon has to be open, in the sense carbon has to be less sterically hindered. So between carbon A and carbon B, which one is less sterically hindered, where I minus can come easily and then do the substitution. A has two methyl groups and a hydrogen. B has two hydrogens and one methyl group. So the B would be the most easiest one to attack by iodide. So the iodide would come to the more open carbon and then cleave the bond between carbon and oxygen and going to form these three. So it's going, these two products, CH3, CH, CH3, OH, alcohol, and CH2, CH3I. So that's the ethyl iodide that's going to form. Okay, it's not going to attack to carbon A because it's more sterically hindered, since this is going to happen in SN2 fashion. Okay, and then the number 20. I'll start from number 20 in another session.